Hello girls and boys, welcome to Blackboard Techniques. In this video, we'll be solving the problem number 7 in exercise number 1.4. In this video, we'll be solving the problem number 7. Okay. If you check out my playlist in English, you'll be able to find out all the previous example problems and exercise problems. The video link is in the description box below. Do check it out, it would be helpful for you. Now we'll solve the question number 7. In each of the following cases, state whether the function is bijective or not. Justify your answer. Okay. Here two functions are given. We need to check whether this function is bijective or not. Okay. First option is function colon r tends to r defined by f of x is equal to 2x plus 1. Second one is f colon r tends to r defined by f of x is equal to 3 minus 4x square. Before starting this problem, we need to know what is bijective. Here, what is bijective? Bijective is nothing but if particular function is bijective means that function should satisfy two conditions. Whether the function is one-to-one function and that function should satisfy onto condition also. Okay. Once you get it in the problem, we'll be able to find out the answer. Let's start solving the problem now. Now we can start writing the solution. Here I have written the question. Okay. First question is f of x is equal to 2x plus 1. Okay. Here, before that, we need to know what is bijective function. What is bijective function? If particular function satisfies, now we can write what is bijective. Okay. If particular function satisfies both one-to-one condition, one-to-one and onto. Okay. Onto. If particular function satisfies both these two conditions, then the function is called as bijective function. Okay. First, we have to check whether the function is one-to-one. Okay. What is one-to-one? If suppose we have two sets, first set and second set, first set of first elements, set element should have the relation with other element of other set. Okay. All the elements of first set should have the relation, that is one-to-one function, that should be unique. Okay, unique. All the outputs will be unique. So now we are going to check whether this function, what is the function? First one is f of x equal to 2x plus 1. Okay. Here we are going to check this f of x function is one-to-one or not. Here, for that, we are going to provide the different values for x. Okay. We can say here this x is input. We can say x is input. This f of x is, can say y. We can say y, or else we can say output. Okay. Output. And here we are going to provide different values for x, that is input, and we'll be getting answers. Whether it is different, whether all the outputs are different, we can say this function is one-to-one. Okay. Now I am going to provide the value for x is 0. Here what is r? R is given, right? Here this R2R means real numbers. Real numbers will be having 0, minus, negative numbers, positive numbers. I am starting from 0. I am providing x is equal to 0 first. So that what I will be getting? If I am giving 0 for x, f of x would be 2 into 0. 2 into 0 plus 1. 2 into 0 is 0 plus 1. Answer is 1. Okay. For 0, I'm getting output as 1. And next, I'm going to give the value for x is x equal to 1 plus 1. Then, what should be the answer of f of x? 2 into 1 plus 1. So, answer is 2 into 1, 2. 2 plus 1, 3. We are getting different answer. And now I am going to give x is equal to minus 1. X is equal to minus 1. Then what would be the answer? F of x would be 2 into minus 1 plus 1. So answer is 2 into minus 1 minus 2 plus 1. Minus 2 plus 1 minus 1. Okay, we are getting different answer. So if we are drawing arrow diagram with two sets, what we will be getting? Let's see. This is just assume this is x, this is f of x. Okay, this is input, this is output. So here I am giving x 0 and getting 1. And next I am giving 1 for x and what I am getting for output 3. 3, right? Yes, 3. And then next input is minus 1. Answer is minus 1. Okay, here the relation will be like for 0 only we are getting 1. For 1 only we are getting 3. For minus 1 only we are getting minus 1. So different outputs for different inputs, right? So here one-to-one function satisfied, right? This function is one-to-one. Why? Because all the elements in the x set will be giving different answers, different outputs. Whatever input we are giving for x will be giving different answer. So it is satisfying that one-to-one function. This is one-to-one. Okay. And now we need to check whether it is onto or not. Onto means second set of elements should have the relation. Okay. Second set of element should have at least one relation with other element of other set. Here this condition also satisfies, right? Every element is having the relation. So this function satisfies one-to-one condition, one-to-one condition and onto condition. So that this function tends to be a bijective. Okay, bijective. So the answer should be like this function f of x is equal to 2x plus 1 function is the bijective function. Why? Because this function satisfies both the condition one-to-one and onto. So that this function is bijective. Okay, this is the first answer for first sub question. Next question is, let's check it out. Next question function is f of x is equal to 3 minus 4x square. Okay, we have to write the answer for first question like this function f of x, what it be? You can write this f of x equal to 2x plus 1, right? Is bijective because it satisfies both the condition. It satisfies both the conditions 1 to 1, both the conditions 1 to 1 and on to, so that this function is bijective. Okay, next one. Next one. What is next question? Next function is f of x equal to 3 minus 4x square. Here also we are going to check whether this function is bijective. For that we need to check whether it is one-to-one function and onto function. If it satisfies both, we can say this is bijective. Okay. Now we are going to check one-to-one first. For that I am giving the same thing. I am going to follow the same thing what I have followed in my previous question. Now I am giving x is equal to 0. Then what will be getting f of x is equal to 3 minus 4 into 0. So 3 minus 4 into 0, 0, right? So answer is yes. And next we are going to provide x is equal to 1. X is equal to 1. If I am giving 1, what would be the answer of f of x? 3 minus 4 into 1 square, right? So 3 minus 4 into 1. 3 minus 4 is equal to minus 1, right? So next is x is equal to minus 1 I am giving. X is equal to minus 1. So f of x would be 3 minus 4 into minus 1 the whole square. So 3 minus 4 into 1. So answer is 3 minus 4. 4 into 1, 4. So answer is minus 1. Okay. So if you are drawing arrow diagram, here what is the thing? Two outputs are same. Look, if we are providing x is equal to 1, we are getting minus 1. If you are providing x is equal to minus 1, we are getting minus 1. It's not different output. It's same output. Okay. So it's not satisfying onto one-to-one function, right? If you are drawing arrow diagram, this is arrow diagram. If you want to draw the arrow diagram, what should be it look like? This is x, this is f of x. What are the inputs I gave? 0, 1, minus 1. What I have gotten? I have gotten this 3, 0 for 3 for 0, minus 1 for 1, and again minus 1. We have gotten 3 and minus 1, right? 3 minus 1. For 0 also we are getting 3, 3. 1 also we are getting minus 1. Minus 1 also we are getting minus 1. So here two outputs. This two outputs are same, right? Here minus 1, here also minus 1. So this is not satisfying one-to-one. This is not one-to-one function. So there is no need to check whether it is satisfying on two functions. Already it is showing that it is not a bijective function. Okay, why? Because it is not one-to-one function. all the elements of first set should have the relation, but all the output should be unique. Here, for two different inputs, we are getting same output. So it is not a one-to-one function. So it shows that it's not bijective function. Okay, this is not a bijective, not a bijective function. Why? Because it is not satisfying one-to-one and on-to function. Okay, this is the answer of second sub question of problem number 7 in exercise 1.4. This is very easy. If you know the concept, you'll be able to answer. This much I had in this video. We'll see in another video. I hope this video helpful. If you find this video helpful, give thumbs up, share it with your friends, subscribe to the channel Blackboard Techniques. Bye for now. Shiny signing off. Thank you.